Sorry, Esaku is a
Yes.
two, and Sataki is itu. Oh no. Sorry, I'm just checking the attendance, the attendees.
I think I have to refresh. No. This is not Dr. Fujimura. So I'm right. So I think it is 1 minute past 2. So I think while waiting for a couple of panelists to join, I think we can slowly start. And very warm welcome from from Geneva as the Secretary of the Minamata Convention on Mercury. And this is one of the science stream of the Minamata Online, which is an online initiative that the Minamata Convention Secretariat started last year. And this year, we fully cooperate with the ICMGP, International Conference on Mercury as a Global Pollutant. And the first part of the season 2 science stream are dedicated to the synthesis papers that that will be presented at the ICMGP 2022. This is the fourth one and last one of this series. And from next month, on the 17th of November, we are going to start another initiative, which is linked to a mini workshop that will be convened at the 2022. The schedule for that series will be announced soon. So I think I'm not going to spend too much time on on this introduction, but if you go to the next slide, I'm just going to remind you about the housekeeping notes, and there may be as you see in the point 3, there may be time for oral questions. So if the moderator invites some, and if you wish to take a fall, please raise your hand. But perhaps we may look at the questions in the chat box. So if you have any sorry, I think what was the so sorry, Q&A panel. If you have questions, please use the Q&A panel, Q&A box. I think you should have the Q&A box. Yes, you should be able to open the Q&A box by clicking on the 3 dots at the bottom of at the right bottom of the screen, and please send your please put your questions on the Q&A box and send to all panelists so that panelists can see these questions. And then as the last point, please note that this session is recorded and broadcasted. And this is broadcasted by YouTube stream, and also the recording will be made available from the website together with the presentation slides. So with this, I'd like to hand it over to Joy, who is the co-chair of the ICMGP.
Good morning, good afternoon, everybody. So I'm just going to take you and welcome also to the session. So I'm just going to take you over the presentation of the ICMGP for 2022. You will find this is a partnership between Minamata Secretariat with ASACU, thank you ASACU, and the ICMGP EXCO, or the conference conveners for the next virtual event. As you all know, it's now between the 24th and the 29th of July 2022. Next, and you can find more details at the website listed there. Next slide. The EXCO, thank you. Next, there we go. The executive committee, because it's a virtual committee, a virtual conference next year, because of the COVID pandemic, we've had 3 more additional EXCO members join us. So the top 2 rows were the original for when the conference was to be in Cape Town, and the bottom 3 is they joined us in July 2021 to make it more international. And maybe I should also say that the theme for the conference in 2022 is reducing mercury to achieve a greener world. And so slightly different to what the 2024 conference is, but we are living in a world where we would like it to be greener. And then next slide. So we've had 3 calls for, we had a call for workshops for mini proposal call. We also had a call for Lifetime Achievement Award, and then also the Emerging Research Award. And those calls have closed on the 8th of October. And we still have 1 call that is open, and that is due on the 30th of October 2021. And that is the call for special sessions. So, how many days does October have? I'm now not sure. I think it's 31st October. My apologies. So it should be 31st of October 2021, and there's criteria that is listed and can be found on the website. Next slide, please. And then just the work in progress, obviously, is that we've put on hold for now the conference in 2024. So 2022 virtual, and then in 2024, the conference will be back in Cape Town. Thanks, Aisaku, and all of the best to all the presenters today. Thank you.
Thank you, Joy. And then my job is just to hand it over to Neil.
Great. Good morning, good afternoon, good evening, everyone. My name is Neil Basu, and I'm a professor at McGill University in Canada. And it's my privilege to introduce the topic and the research team. Next slide, please. So I'm honored to be part of this team. The names listed here, and you're going to hear from most of them momentarily, they represent some of the most important health researchers in the mercury field. They really have run some of the most policy influential studies of our time. And together, what we're hoping to do is to paint you a picture of mercury health research and how it's evolved from tragic poisoning events and iconic case studies, from select geographic regions and population groups, to one that's more globally representative in terms of studies that really start to capture the nuance and the variability in terms of mercury exposure and risk worldwide. So the names are listed here. And again, you're going to hear from them momentarily. And as Joy mentioned, our team represents a health plenary team that's scheduled to give a presentation at next year's International Conference of Mercury as a Global Pollutant. And what we plan on doing today is to give you a glimpse into the work that we're starting to pursue. Next slide. In terms of an outline, I'm going to start by giving some opening remarks, and then I'm going to pass off to my colleagues who are going to take you on a journey around the world to various case studies that they lead and have deep knowledge of. Then what I'll do is to sum up the presentations and then pass off to my colleague, Professor Horvat, who will handle the Q&A. Next slide. So as all of you know, the Minamata Convention on Mercury really exists because mercury poses a great threat to human health worldwide. And Article 1 makes this very clear that at the beginning of the convention, that the ultimate goal of the convention is to protect human health. We all know that populations worldwide are exposed to some amount of mercury, but there are notable vulnerable groups which have special mention throughout the convention text. And momentarily, you'll hear stories from some of these vulnerable groups. So the evidence that mercury is a risk to human health is quite clear, and this has been clear for decades. Though with more and more research that is starting to look at the more subtle and diverse health effects, and with more and more research in different parts of the world and in different population groups, we're starting to both broaden our understanding, but also deepen our understanding on the true holistic health impacts of mercury. Through all of this, we're able to really start to understand some of the most important socio-economic, environmental factors and drivers that underpin health in this area. And with all of this information, we're able to start getting a bit more proactive about how we do mercury health research, how we harmonize research across different settings, how we compare and contrast findings in different settings, how we put these findings into policy and action. Next slide. So now that we understand that mercury is a risk that varies tremendously around the world, it's really important to emphasize that the risks in one place, in one population with one source of mercury may not be and likely are not the same as in different places and in different populations. We know that there are different chemical forms of mercury that exist in different products and different sources. These can vary worldwide. And as such, our exposures to them can vary on a worldwide basis too, and their health impacts can vary worldwide. In terms of classical questions that focus on mercury-contaminated food items, we know that levels can vary in a range of food items. Classical studies that focus on fish, for example, have made clear that mercury exposure and mercury content in things like tuna and salmon are quite different. And newer studies are starting to expand our understanding that there might be certain populations or areas in which other food items, such as rice, might be important. We know in certain parts of the world that the consumption of marine mammal meat can be a tremendous source of exposure. Even if we take one particular food item, for example, tuna, these can also vary tremendously worldwide. The mercury content in different types of tuna in different ocean basins can vary. We know that tuna that's eaten in a sashimi fresh form can be quite different than tuna that's canned, or sometimes tuna is just blended up and put into soups. So we can't look at tuna very simplistically. We need to understand the context that the tuna is being consumed in. We've known over a long time through classical studies that the health impacts in children are very, very different than in adults. And while we know that males and females are different and that the rich and poor are different and healthy and sick are different, these are newer dimensions that we're starting to see infused into the mercury health literature. We know that studies from Japan, the Arctic Inuit, the Seychelles, across Canada and elsewhere have been highly important and influential. But we also know that these populations are quite different. We know their mercury sources are quite different. Their exposure routes are different. Their population characteristics are different, so on and so forth. And ultimately, the risks that individuals from these areas experience are different. Next slide, please. So all of this is quite obvious, but what we propose is that in our texts, in our presentations, in our discussions, that we often tend to generalize and sometimes even misrepresent mercury risk in various scientific and policy arenas. But we really want to emphasize that risk is context dependent. This is particularly important because, as we've mentioned, there's this tremendous socio-economic environmental dimension to mercury. And as such, sometimes understandings and decisions in one part of the world and in one population group may not work well in a different area. So we believe that operationalizing the convention to really understand the health risks of mercury and ultimately reduce it requires empathy and understanding of this diversity and variance in populations worldwide, and in particular, the socioeconomic drivers. Next slide. So we started to see this happen in the latest UN Global Mercury Assessment report. There was a map in the Human Health chapter that started to draw attention to diverse sources of mercury worldwide as an attempt to start to paint this global and worldwide picture of this variation. Next slide. And in that same report, we started to also look at biomonitoring data. So this is a bubble plot, and on the x-axis is the concentrations of mercury in hair. This is a type of mercury that's likely coming from dietary sources, methyl mercury. And on the vertical axis, going up and down, is concentrations of mercury in urine. This is largely being realized in populations through exposure to inorganic forms of mercury. And each of the bubbles here represents different geographic regions according to the World Health Organization. And what we can see here is on a global basis that we see different exposures to different forms of mercury in different parts of the world, but also that there are some areas of the world, such as the Americas and Europe, that have been largely and well studied in terms of mercury exposure. But there are other parts of the world, such as Africa and Southeast Asia, for example, that have relatively little data. Next slide, please. So with that being said, again, the objective of our synthesis paper at the next conference will be to help stakeholders, so people in this webinar, those that are working on policy for the Minamata Convention, our fellow mercury scientists, both in the health field and beyond, to really help all these groups gain a deeper empathy and understanding of the diversity of mercury in populations worldwide, really looking at this from the past to the present to the future. In doing so, we aim to string together a story that is based on socio-environmental economic case studies by leading experts in the field, and then to synthesize this information. Next slide. So this provides a snapshot of the presenters today. What they do is that their pictures are tagged with different geographic regions, and in a moment, we're going to start to go through this. So I get the honor of going first to talk about the Arctic. So next slide. So in terms of the Arctic, I speak here both as a researcher that has done work in the Arctic, but also the co-lead of the current human health report as part of the 2021 AMAP Mercury assessment in the Arctic. And human health impacts and risks in Arctic populations is really of worldwide concern, and this is exemplified in the preamble of the Minamata Convention, which notes, and I quote, the particular vulnerabilities of Arctic ecosystems and Indigenous communities. So we've known for a long, long time that the mercury issue in the Arctic is particularly of concern and one that warrants attention. Findings from the last Global Mercury Assessment report and previous AMAP reports have continued to show that Arctic populations are amongst the most highly exposed to mercury worldwide, and that this is largely being realized through the consumption of traditional foods that are contaminated with methyl mercury. Next slide, please. This is not surprising because the food chains in the Arctic are very, very long, but also very, very focused on the consumption of traditional foods. So we tend to see that apex fish, seals, have mercury content that can be 1 million-fold higher than levels in the environment. And these types of food represent important dietary components for Inuit and other populations in the north. With that being said, we're also starting to see that climate change is starting to impact the biomagnification of mercury up the food chain. And it's not necessarily clear what this will mean for individuals in the Arctic in terms of their mercury exposure. And we also know that this can vary tremendously across different locations in the Arctic. Next slide. So what the data shows, and this is coming from the forthcoming AMAP report, is that when we take a look at some of the most important food items, we do have tremendous information on mercury content in these food items. We have thousands and thousands of samples from dozens and dozens of locations across the circumpolar north that have been tested for mercury content. If you look at the average and maximal concentrations of mercury in these food items, they're relatively high when we consider concentrations in food items found in other parts of the world. In addition to having relatively high concentrations of mercury in the food items, we also know that communities in the north tend to eat a lot of these types of foods. We're talking about grams and grams of these particular food items being consumed a week. Next slide, please. It's not surprisingly then when we look at blood and other biomarkers in Arctic populations that we start to see relatively high concentrations. Even though we don't have good representation around the circumpolar north in terms of biomonitoring data, in areas in which mercury has been examined through a biomonitoring and biomarker-based approach, the data has shown that the levels are relatively high against amongst the highest worldwide. The data also show that when we look on a temporal basis at concentrations from about the 1990s until now, we do see that the mercury levels in the blood coming down. One may conclude that that is likely due to reduced amounts getting into the Arctic, but we feel that it's largely being driven by a change in diet. Next slide. So we do see this dietary transition in the north, and this in itself is of concern from a public health perspective, because we know that traditional foods, again, these same foods that tend to have mercury in them, are really key to health in the Arctic. So key to population and their spirituality, their culture, their physical well-being. But with more and more news that these food items might be contaminated, but also issues related to accessibility and food insecurity, we're starting to see that many communities in the north are consuming less and less traditional foods. And as such, this is believed to be what's driving reductions in mercury exposure in Arctic populations. Next slide. So in terms of risks and health impacts in the Arctic, again, as I mentioned before, that epidemiological cohort studies on Arctic populations have been some of the most influential worldwide in terms of demonstrating that early life exposure to mercury can be associated with later life adverse health outcomes, largely in the neurological domain and a bit in the cardiovascular domain. We have seen evidence from the Faroe Islands and Nunavut being particularly important and exemplary in terms of scientific knowledge and understanding, but also informing the Minamata Convention. Much of the evidence thus far in the Arctic is focused on neurodevelopment and cardiovascular impacts, with interest in other health dimensions being researched by others. An important aspect of this type of work in the north is that these exposures are being realized through a traditional diet and the nutrients that these diets contain, and these afford tremendous benefits towards neurodevelopment and cardiovascular impact. So it's important that when these studies are done, that the risks and the benefits of consuming traditional foods are properly examined. And risk communication is difficult. It shouldn't be a permanent solution to the issue of mercury in the Arctic, but it needs to be done, and it needs to be done in a participatory manner with communities. Next slide. So with that being said, we're going to go from the Arctic in the north to the Pacific Ocean, and I'm going to pass it off to Dr. Schroff.
So thank you, Neil, for sharing mercury risk associated with the Arctic region. And my name is Emlyn Schroff. I'm from the Seychelles, and I'll be talking a little bit about the Seychelles experience. So for those who do not know where the Seychelles is, it's not in the Pacific. It's actually a small group of islands located in the Indian Ocean, east coast of Africa. So the landmass itself is very, very small, but those islands are dispersed over a wide area called the exclusive economic zone. So consequently, we highly exposed to a vast area of ocean, which is very important for us, not only culturally, not only for economic activities, but it's a main source of income. As such, Seychelles is known to be one of a country with very, very high fish consumption. And per year, on average, person can consume up to 57 kilograms of fish. This translates to about 10 fish meals per week. So, of course, with such high fish consumption, there is the concern associated with the safety of mercury in those fish. And the Seychelles has actually carried out research for over 30 years. And in fact, we have the longest longitudinal studies looking at prenatal and postnatal mercury exposures through fish consumption in multiple cohorts. So the Seychelles has been an ideal epidemiological site for such study. We being very small, there's a very, very few industry here. Therefore, environmental pollution is at a minimal. consumption of sea mammals, where there has been a lot of bioaccumulation and concentration of methylmercury is illegal. So people are not allowed to eat these sea mammals here. Education and health are universally free and available. And we've seen throughout the years that there has been a very high retention rate of participants in our study. In fact, 80 to 90% of the participants return even 20 years later. So in fact, the Seychelles has been a great site to understand the influence of methylmercury from fish consumption, especially on children's health and development. Next slide, please. So in this slide, I just wanted to highlight the extensive study done over the last 30 years. So primarily, there has been several cohorts of mother-child pairs that has been recruited over time. And as you can see, the numbers of mother-child pairs in each cohort is quite extensive in this throughout the year. So there's been a number of biosamples collected, including hair, blood, cord blood, information from food diaries, dental amalgam, and all of this collected over time. And children has been actually assessed for neurodevelopment and neurobehavioral from early, from birth, 1 month onwards, through childhood and adolescent, and even as young adults. So what has been interesting with the Seychelles study is that when we assess for maternal hair mercury level, we see that it ranges quite wide, from 1 to 30 parts per million, with a mean of 6.8 parts per million. So, but when we do the all the assessment, neurodevelopment and neurobehavioral assessment that includes cognition, psychomotor development, social communication, language development, executive functions, to name a few, we see that these children and even young adults, they score very well on all of these tests. So our findings from these assessments, if you can go to the next slide, please. Next slide, please. Shows that there has been no adverse effects on neurodevelopmental outcome amongst children and young adults from prenatal exposure. In fact, we even see that some of those children that were exposed to higher level of mercury, they tend even to perform better on some of those tests. So the finding of absence of adverse effects became very interesting for us, and pointed to the fact that perhaps there are other beneficial factors in fish that's providing protective effect from methylmercury exposure. And this is when two of our cohorts, that we call the nutrition cohorts, especially NC1 and NC2 here, became very important for us to help us further understand the importance of nutrients in fish. So next slide, please. Okay. So fish is an essential source of food, but it also contains very important macro and micronutrients. So one of the key findings was that N3 long-chain polyunsaturated fatty acids, PUFA, which is beneficial for brain development, may be playing a key role in modifying the influence of methylmercury. In fact, if you focus on the two bar charts at the bottom, you can see that different types of fish, fish from different region of the Seychelles, from different types of fishing practices, offer very high levels of N3 PUFA. And from analysis done, we can always see that amongst mothers with higher N3 PUFAs, even in the presence of increasing methylmercury exposure, there's always some kind of improved association of psychomotor development index that we've assessed. We know other types of micronutrients are also important in altering the risk of methylmercury, such as selenium, which is also found in the Seychelles fish. Next slide, please. So I wanted also to highlight the type of or the levels of methylmercury seen in fish in Seychelles. So here's an example of fish from different location and from different fishing activities. And from a project which analyzed from 54 species of fish, you can see that the levels of methylmercury in the Seychelles fish is below the recommended limits, which is 1 ppm for large pelagic and 0.05 for all other species. So this level is considered to be low compared to commercially available fish in developed countries. Next slide, please. It's interesting because when we also compare mercury levels in the Seychelles fish and also look at other types of metals such as cadmium and lead, if you look at the three top charts, in orange are the levels of these metals in the Seychelles fish, and you can see it's much lower compared to other regions of the world. Also, looking not only at mercury but other pollutants such as PCBs and DDTs, you can see that in the Seychelles fish that these pollutants are found at much lower levels. Next slide. Next slide, please. So in conclusion, it's important for us to remember that fish is a natural source of protein for billions of people worldwide and contains very important micro and macronutrients, which is important for growth and brain development. We have seen that there is no adverse effect seen in the Seychelles population over the 30 years of study, but rather that there's beneficial effects as seen in early years of life from prenatal fish consumption exposure. Levels of methylmercury measured in Seychelles fish is considered low, and we have evidence that PUFA plays a beneficial role, especially the high N3 to N6 ratio, which is also found in our fish. So the population is not too different from other parts of the world, because when we look at certain covariates measured, we found that there's always similar outcomes. So this indicating that our population is fairly similar to other population. So message that I think we can take from Seychelles is that we need to understand that the balance between protecting human against the toxic effects of mercury, but at the same time promoting fish as a good source of micro and macronutrients and for human development and health. Thank you. Neil, I pass it back to you.
Great, and I thank you for that wonderful presentation, Dr. Shroff. I see that Dr. Fujimura has now joined. So Dr. Fujimura, do you want to take us to Japan?
Oh, thank you very much, Dr. Baz, for your kind introduction. And thank you very much Dr. Tada. So I can log in this system. So I'm Masatake Fujimura and belong to National Institute for Minamata Disease in Japan. I'd like to talk about characteristics of Asian food culture today. So Asians have higher seafood mercury intake than non-Asians. Increasing per capita consumption of fish and shellfish is global trend, but especially in Asia and Oceania, where fish eating habits are naturally strong. And there is a marked increase as living standards improve. In particular, growth is conspicuous mainly in emerging countries, such as about 9 times in China and about 4 times in Indonesia in the past half century. Next slide, please. So, Japan has a unique food culture. The Japanese have been eating whale meat. You can see the slide. And utilizing whale bones, blubber, and oil for more than 2,000 years. Although the 1960s, the supply of whale meat was gradually declined, and accordingly consumption was being reduced. Some whaling remained within the traditional area, where it still plays an important role as the basis of solidarity in community, especially Thai region. This is Taichi Town is located on the Pacific coast of Japan. I think there are various opinions about whale eat culture. However, discussion about the pros and cons of whale food culture is another matter. Next slide, please. So, NIMD, to which I belong, conducted a survey on the relationship between mercury intake and neurological symptoms in whale-rich areas. And picture A, you can see picture is left side, shows the relationship between the hair mercury and ages. And picture B for female, for woman. Black circle are residents who have been diagnosed with neurological symptom, and white circle are residents who have not been diagnosed. The subjects were 194 residents, 170 males, 77 females, age from 20 to 85 years old, who resided in the coast town of Taiji, the birthplace of traditional whaling in Japan. And the genetic mean of the hair mercury levels was 14.9 microgram per gram. 12 subjects revealed hair mercury levels over 50 microgram per gram, and set by WHO. Hair mercury levels significantly correlated with daily whale meat intake. You can see a right side slide. Next slide, please. So, detailed neurological examinations, audiometry, magnetic resonance imaging, and electromyography were performed to diagnose neurological defects. Furthermore, whole blood mercury and selenium levels were measured in 23 subjects. A significantly positive correlation between whole blood mercury and selenium levels was observed. And the whole blood mercury selenium molecular ratio of all subjects were under 1. You can see left side. It's thought that selenium compounds have an antagonistic effect on toxicity of methyl mercury. Multivariate regression analysis demonstrated no significant correlation between hair mercury levels and neurological outcomes, whereas some of the findings significantly correlate with age. These findings suggested that sufficient selenium intake might be one of cases of absence of adverse effect of methyl mercury exposure in this study. Next slide, please. So you can see, some reports have described positive methyl mercury toxicity in adults with hair mercury levels under 50 microgram per gram. And these were reported of studies conducted on inhabitants in Amazonian basin, which demonstrated that disorganized movement during alternating movement task, as well as discrete color discrimination capacity were observed with increased total hair mercury levels under 15 microgram per gram. Nevertheless, in our study, neurological specialists did not detect impairment of skilled motor activity in the subject with high hair mercury levels over 50 microgram per gram. Further study, including analysis of serum selenium levels, will be needed to explain the difference between the result of Amazonia study and our study. That's all. Thank you very much.
Great, Dr. Fujimura, for that perspective from Japan. We will now move to South America, and we'll hear from Dr. Dorea, who is a professor emeritus at the University of Brasilia. Dr. Dorea?
Thank you, Neil, for the introduction. Hello, everyone. Please, next slide, please. Let's start with some of the historical data. Next slide, please. Let's start with some historical data collected through the last 30 years regarding fish consumption and hair mercury. From our last study that is in the upper corner, the reference, we have seen a decline in the traditional populations that live basically on fish and eat every day. And as you can see from the right-hand column, the levels of fish consumption ranges from 30 grams a day to sometimes 260. These were studies measured by different methods, ranging from questionnaires for fish consumption or derived from data of hair mercury concentration because of the close relationship of the methylmercury in fish and the methylmercury in hair of these populations. One thing that I would like to call attention to the audience is the diversity of habits and fish consumption and mercury exposure for this vast region of the Amazon in South America. It's a region with an area larger than Western Europe. It has like 70 countries, and with native and indigenous people of different backgrounds and different hunting and gathering experiences. And some of the people that went and developed the Amazon more than 100 years ago. And they live in situations that sometimes researchers fail to realize such differences. When you live by the main course of a large river like Madeira, Tapajós, Negro, it's like a very large highway that has seen the development of the Amazon, and with it, the transformation of their lifestyles. When you live in the smaller rivers, the affluents and the igarapés, the situation of isolation is aggravated by the annual flooding of the spring floods of the Amazon, and complete isolation. They developed a culture of a very high food consumption. And you can see from 30 to 262 grams a day or daily feed per shepherd, twice a day, sometimes in some of these communities. Both what we call riverines, which are a population that mixed with the native population that the Europeans found in South American continent. Sometimes they have even more daily fish consumption than the Amerindians, the native population. Next slide, please. But sometimes our focus of our research, going back a little bit, has been not only on fish consumption, but contamination from artisanal gold mining activities and other forms of mercury exposure. One of them that we've been sort of exploring with more intense the organic form that's not accounted in many studies, but it is present in almost all the developed countries of the world, which is the exposure to authentic mercury in the form of ethyl mercury containing the thimerosal-containing vaccine, which has a schedule that is comparable to the high concentrations of methyl mercury that you find in human milk. Just for you to have an idea, the riverines, which has a high consumption of fish, their milk intake, the children exclusively breastfed, can have like 2.3 as a mean of mercury concentration in the human milk, which puts them in a very high position, which is, I can't find in the literature to compare internationally, but they are the highest exposed around the world. However, it is important to point out that this mercury fish that goes into the milk is not all absorbed. And even if it's absorbed, it's not all retained. Only 5 to 10% of the methyl mercury is retained in the brain, but 35 to 40% of the ethyl mercury that is contained in the thimerosal vaccine is retained in the brain. And hardly when we start the neurodevelopment of children, excuse me, this is never considered. Just in the exclusive breastfed child in the Amazon receive an average of 1.9 micrograms of methyl mercury in the milk, and the same schedule of a full vaccine. You can see in the right-hand corner, the lower right-hand corner, the proportion of one form of mercury that is injectable and 100% absorbed against the other. So in these children, the compounding of different sources of mercury, it's never taken in consideration or hardly taken in consideration. Sorry about this. Another form of compounding that sometimes is overlooked is the association of neurotoxic mineral components that comes in the milk. Just to have you have an idea, most of the binary combinations of neurotoxic components in detectable levels that would be a threat to the neurodevelopment of children is hardly in any amount that could pose any threat to the neurodevelopment of the exclusive breastfed child. Next slide, please. Another point, very sorry about this. Another very interesting point of interest is that we have recently developed studies to check on the correlations of the different matrices that we use to monitor mercury exposure in this population and around the world. Based on the study of Clarkson before, we have a relationship of whole blood to brain mercury of 5 and blood to hair of 255. We have recently measured this in our own population and found real values. Those that you see, it's values developed from models, and the right-hand side is the ones that we just measured. Is about to be part, should be up in a month or so. So we found relationships of hair to brain of 72, 573 for hair and blood, and 6 from brain and blood. Next slide, please. What's interesting, comparatively speaking, with so much of mercury exposure in this region, is that we have different outcomes when we measure these neurodevelopment tests in children. Most of the studies done before taking in consideration lactation, exclusive breastfeeding, and the neuroactive components of the fish, like nutrients like selenium, polyunsaturated fatty acids, we can our results, at least the ones we have done lately, it's more in line in the results that you heard from our colleague from Seychelles. I mean, we don't. Once you measure the confounding factors, some of the trend, some of the mercury association development delays are transient and overcome by the positive effect of breastfeeding. Next slide, please. Which is not the same situation as with adults. In most of these studies, you do find historical accounts that relate some strong, significant association between visual functional tests, functional tests in adults, and some alteration due to exposure to mercury. However, in the adult population, most of these studies, or at least half of the studies shown here, are from people exposed to activities, occupational activities that deals with mercury, like amalgamation in those mining areas. Next slide, please. So, just to give you an idea of the different exposure that we see in the Amazon population, we have ethyl mercury, which is very high, not only in South America, but all over the world in developing countries because of the cost of this vaccine. So this is very high. It's a non-oral type of exposure, which gains complete access to the developing organisms. Next slide, please. The next one that you have seen before is methylmercury in fish. In our case here, we stress the human milk for these breastfed populations of the traditional living people in the Amazon. And another one that's emerging in many parts of the world, and it hasn't been explored yet in Brazil or in South America or in the Amazon for that extent, is food. You know, fish is traditional. It's very well studied. Human milk is studied in many places. And rice is emerging in Asia and in Brazil because of the receding waters of the Amazon. Many people have their crops in the receding waters of the inundated Amazon plain. And we think that would be interesting to start methylmercury in beans and some types of rice that's grown in this area. Next slide, please. In other forms of inorganic and mixed organic and inorganic mercury, which you also find in South America, especially in not necessarily South America, in sub-Saharan Africa and Asia, through traditional medicines and geography, which confounds some of the studies that has been done in Africa recently in relation to gold mining activities. Next slide, please. For the inorganic mercury exposure, there are many other sources, many other pathways that could be food, like cassava and starch root that's grown in contaminated soil. Dental workers and the people that has dental restoration, ASGM, artisanal small-scale gold mining. And another new one that's emerging, especially in Africa and in some places in South America, is waste work, the electronic waste workers, recovering of precious metals that sometimes is a mixture of the neurotoxic components, including mercury in the exposure population. And last but not least, in South America, also we have volcanic activity, like in some other parts of the world, that's not yet deserved the sufficient attention to see the level of contamination in this population exposed to these eruptions. Next one, please. I think that's it. Thank you very much.
Great. Thank you, Dr. Dorea, for that wonderful presentation, starting to now really expand our discussion on variability in various sources of mercury and exposure pathways. We'll now move to Europe, and we'll hear from Professor Milena Horvat, who is from the Josef Stefan Institute in Slovenia.
Thank you very much, Neil. Do you hear me?
Yes.
Yeah, okay. Thank you. So my presentation will be rather short because many of the complexities which we hear from all around the world can be in some way reflected in Europe, but Europe has, apart from national policies, also adopted some European policies to combat chemicals that are toxic for human health. And mercury is obviously one of them. And we have, Europe is as diverse as the globe, but still there are some challenges. And I would like just to address or maybe inform you about what is currently going on in Europe in terms of mercury exposure, health outcomes, and policies that are in place. So we have several European policies, as I mentioned, also apart from national policies that countries adopted. And from a community strategy concerning mercury from 2005, many countries have revisited these issues. We have, of course, EFSA, European Food Safety Administration, that provides advice, gives recommendations. We have chemicals under the REACH directive, which is about registration, evaluation, authorization, and restriction of chemicals. Then there are several environmental policies dealing with surface waters, groundwater, drinking water, emissions and releases, and so forth and so on. And then consumer products are regulated, occupational health, right in place. And moreover, there are other policies, among which, of course, Minamata Convention is the one that is an overarching with all its articles. Next slide, please. Now we have a lot of data that are available and harmonized across Europe about mercury sources. For example, just these 4 figures here, where we have a very detailed information on mercury present in soil and also distribution of mercury contaminated sites. We have heard from previous talk, and especially from Brazilian situation, that contaminated soil can sometimes also be a source of inorganic mercury exposure of humans, so it's not only fish. And then we have, of course, the emission data from various sources, as you can see. There are various like fossil fuel burning, high temperature industrial processes, waste incinerators, chloralkali plants sometimes still in operation, where mercury can be emitted to the air in its elemental mercury form, and people living nearby potentially can be exposed to high levels of mercury than in other places. Then we have, of course, information on fish consumption, not only on a country level, but regional level. And there were several studies done by which we know much better which kind of fish people consume, not only in the terms of mercury content, but also in terms of nutritional value of fish, similar to what we have heard from Seychelles. Obviously, use of dental amalgams have really been reduced recently in most of the European countries, but as we will see, the level of exposure at the moment seem to be quite low, and still we can see that obviously dental amalgams can contribute to exposure to elemental and inorganic mercury. And then we could go on and forth with this, but no time really to discuss here. I would also like to say that we have very nicely organized databases on mercury levels in fish in the GMOS database, where we also find concentrations of mercury in air, in ambient air, obviously, and also in water. Next slide, please. Now, talking about, obviously, we have, as we know, also a population that consume more fish that contain higher quantities of mercury. We know the FARO study. Paul is here. He can probably mention or say a few words later. But also in the Mediterranean countries, very nice long-term epidemiological studies were implemented. And it's very interesting that even the levels of mercury in fish seem to be much higher than what we see in the Indian Ocean, like in Seychelles. We see that people consuming fish and the children perform even better because of the nutritional value of fish. So that this dilemma that was presented by Dr. Schroff, in fact, is there. Now we see that we have a lot of data from human biomonitoring campaigns. These are some that are officially implemented in particular countries in Europe already for some time, and we can see also some trends of reduced exposure to mercury over time, or in increase, obviously. And mostly these markers are either blood or hair or urine, and we know that each of these biomarkers can indicate to what people are mostly exposed. But now when we look at the European population, we find very interesting results. Maybe we can move now to the next slide. This is just to show that as we come close to the seaside, the levels in biomarkers will be increased, especially in hair and blood. But what we also see in data that have been published since 2013 is that people consuming fish will also have levels elevated in the urine, which I think at this low level of exposure is more evident than what we would expect, because we know that mercury in urine reflects the concentration of mercury accumulated in kidney, and this is somehow believed to be correlated directly to inorganic and elemental mercury exposure. But we also see in fish consumption, in population consuming fish, also we see that some of this mercury in urine reflects most probably methyl mercury is decomposed and then excreted as inorganic mercury. Next, please. Very interesting phenomena that we also see. We recently reviewed a lot of the papers and looking into urine as a biomarker from HBM studies. And what we see is that we see an increased levels, not only in people consuming fish, but also in contaminated sites, and people living close to waste incinerators may indicate high levels of, but still very low overall. It has to be mentioned this very clearly, that we are talking here of the levels below 5 microgram per liter, which is lower than HbM1 level. So we are just observing the difference among different potential sources of mercury to different mercury species here. And next slide, please. And here an interesting work from 2016 where they were looking into people living close to waste incinerators, and we still see that the levels in urine will reflect the number of fish meals or the number of amalgam fillings. So there is this interesting phenomena. Though we have low level of exposure, we have to also consider that we are not only exposed to organomercury compounds, but that we have also continuous also exposure to inorganic mercury, as well to elemental mercury in specific subpopulation groups. Next slide, please. So what about research and development in Europe? There were many studies already implemented that are either national programs, coordinated human biomonitoring programs that provided values, reference values for various groups and populations where we can see spatial and temporal trends, of mercury exposure. There are very nice epidemiological studies from which we can also learn from. Now, within the European Union Framework Program, these are the studies that go beyond the national priorities. So it's really putting together collaborative frameworks. And here I would really like to draw your attention to the activities that are performed within European Human Biomonitoring Platform. This is a project, a very large project coordinated by UBA from Germany, and where most of the European Union countries and some associated countries collaborate. Now, this is not only about mercury, I have to say. Mercury, as it is indicated here, has become a priority substance only in the second round, but many very interesting activities are ongoing, and all the information is available. It's openly available for everyone. Next slide, please. And what is very important to mention here, I think this is the largest and the most important study right now that really harmonizes not only the research work, but really trying to drive this research to answer some of the important policy-related questions for mercury. For example, how effective are all these policies in place to reduce human exposure to mercury in Europe? How can harmonized, validated, and comparable information, which I think is really an important issue, and this is very well coordinated by Spanish partners in this project. Then what biomonitoring and exposure data on mercury and its species are relevant for European population? I just highlighted that we are maybe not at the higher exposure level, but then we see these differences of organic, inorganic mercury that still need to be somehow looked at closer. And what is the geographical spread in current mercury exposure? Taking into consideration seafood consumption, living close to point sources, or, for example, living in contaminated sites. Are there any different situations comparing north and south and east and west of Europe? Which population remain vulnerable to health impacts from mercury exposure, and how these can be protected? How can the public be informed? And this information that needs to be provided for people to trust the information and then follow these recommendations. And it's not only for population, but especially for professionals that can pass this message to the people. And then obviously, I mean, here always this question is, we cannot talk, like Neil nicely said at the beginning, elemental mercury is not inorganic mercury, and inorganic mercury is not organic mercury. And not only that, I mean, there is a person that is maybe exposed to low level of exposure over a very long period of time and co-exposed to a number of other chemicals which we are exposed to in our daily life. This will have to be considered, and all those that are more sensitive and vulnerable from a genetic point of view. And then, of course, this is what is mentioned under 9, and then 10, what factors make people more susceptible. Again, I don't need to overstress this. I would also like to say that these activities are very nicely coordinated by the partner from Cyprus, from Adrumachi Katsonori, and many partners that are also collaborating. And we are going to provide really a very nice and coordinated picture that can then have a more policy-related message for the European countries and those that are involved in these activities. With this, I would like to finish my presentation. Thank you very much for listening.
Great. Thank you, Dr. Horvat, for that wonderful synthesis from the European perspective. We will give our final presentation to Dr. Zastinskaya from the World Health Organization.
Okay, hello everyone. I got a message from my SACO that we are a bit behind the time schedule, so I will try to be as brief as possible. And will draw your attention to the main facts in order to say about what is going on nowadays about exposure to mercury globally and potential health effects. So on the screen, you see a summary of collecting information and overall gathering of knowledge is rising exponentially about mercury, and the Minamata Convention really give very positive impact on that. But I would like to say that it is the, let's say, the expected development of collecting information, because starting from the mid of previous century, we know a lot about mercury, but we should be very honest that it was massive poisonings and clinical symptoms and investigation of occupational exposure. And Strategy in Minamata and Iraq also provide us information about the mercury health effects. But after that, we investigated the subclinical effects, and that means that not having clinical symptoms or not investigating, not observing clinical symptoms doesn't mean that there is no mercury impact, because we are talking about functional and physiological disorders which can determine and influence on our well-being through the life course. And fortunately, we're now getting more and more information from different regions in order to see the overall picture of exposure and effects of mercury. Next slide, please. So having this information, we really can learn more about the vulnerable population groups. I just summarized that it is definitely vulnerable population groups, and this is children in different ages of development, including prenatal exposure. And there are at least 2 more sources of exposure for children than for adults. I mentioned prenatal exposure and also through the breast milk, despite it is not such a big high risk of contamination of breast milk and the body burden of mercury from small children. But however, whatever we are talking about the ICMGP exposure, waste management, food consumption, we always should keep in mind that exposure of children and the mercury impact will be predictably higher than adults, given the specific sensibility of children organism to mercury. And also we need to know and to draw attention to pay attention to that the mercury impact on early stages of development can lead to the health disorders later in life, given the functional disorders and physiological disorders caused by mercury at the early life stages. For example, if we are talking about IQ and the neurodevelopment and behavioral disorders, it definitely will impact the children later in life. And I just put 2 graphs here demonstrating the differences between the cord blood level of mercury, total mercury in different regions, and you can see definite differences between the populations, fish-consuming populations, and the populations that consume less or not such a contaminated fish. And it was also confirmed that the fish-consuming population are most exposed to the methyl mercury and total mercury, and you can see on the right side the biomarkers exposure concentrations. We gathered this information in the WHO latest study when we developed the protocol for mercury HBM, and this is China, and this is rice consumption, contaminated rice consumption, and Ghana, and this is marine food consumption, as well as Russian Karelia, where the contamination of freshwater fish is very high. Next slide, please. And more information we get now from African and Asian, Latin America. And I would like here to recall you to the previous slide. You can see how many symptoms and clinical symptoms are related to the exposure to mercury. But I would say that to collect this information now in epidemiological studies would be a very big challenge if we would not have the information about what is going on with our organism when we are talking about massive exposure to mercury, and having information about how many covariants are influencing the human health in ISGM, both the miners and the communities. It would be really very difficult to identify the clinical health effects and subclinical health effects caused by the exposure to mercury in ISGM. And another what I would like to stress, it is strong WHO decision that all forms of mercury are toxic for humans being, and the central nervous system, cardiovascular system, and kidney are the most let's say, the most sensitive systems of the organism to the mercury impact. Next slide, please. And when we are talking about the inequity and what is going on North Hemisphere and South Hemisphere globally, the dental amalgam is the one of the area where I would say we are more equal than the exposure and occupational environment and fish consumption. So you can see the data from the latest EU assessment of dental amalgam, and their consumption of mercury is much higher than in African countries. And information about their dental amalgam use and how much mercury, what is the mercury demand in Africa. It is, you can see, it is 5-10 times lower than in Europe. Is it true, or it is because the information about use of dental amalgam in Africa is incomplete? I would say that I collected this information for Central Eastern European countries and Africa countries from Minamata initial assessment, which for my opinion is very, very valuable source because it expressed the opinion on governments. And from going through the Minamata initial assessment, my main conclusion is that the health assessment, human health impact assessment, exposure assessment is recognized as a high priority for all countries. What else can we also see here? That there are already many countries, despite of the, even in European Union, the mercury impact or risk from dental amalgam was recognized as relatively low. The discussion on phasing out of dental amalgam is continuing, and it will be assessed till 2030. But there are countries that already phased out, and it is 8 from the European Union and 3 countries from 6, so 50% in the Central Eastern European countries. And also in Afro, some countries, at least as it indicated in Minamata initial assessment, don't use the dental amalgams anymore in their dental care practice. Next one, please. And the one more source of exposure, this is skin lightening cosmetic. And the according to WHO assessment, African, Asian, and Caribbean population are most exposed for the skin lightening cream, mercury containing with high level of mercury. But here we are talking about practically equal exposure of men and women. And there are very few, let's say few countries that produce skin lightening cosmetic, mercury containing cosmetic, but at the same time it is widely spread in the different regions in our country and even in Europe. Sometimes we got information about the products which were bought via the Amazon or eBay or other selling companies which contain mercury with limits that exceeded the limits which are established here in Europe. But you can also see that sometimes the mercury content in skin lightening creams is unbelievably high. So it is like 42,000 ppm. It is really what can impact human health. But at the same time, many countries indicated that skin lightening creams, mercury containing, are of high demand, are very popular, and consumption is increasing, but there is no assessment. And I just provide one example, which really is very important because we know about that, but there are, I think, many cases that are we not aware because they were not diagnosed. In Jamaica, 20-month-old child poisoned by mercury due to his mom used skin lightening cream with concentration of mercury 38,000 ppm. And the next slide. I think that's all from my side. Neil, over to you.
Great. Thank you, Dr. Zastinskaya, for that perspective from WHO. And thank you to all the presenters. We're at the end now before we go into questions. Hopefully this gives you a sense of our paper and where we're taking our analysis. Hopefully it also gives you a sense of the variability and the evolution in terms of mercury health research from the past to the present and the range of diverse situations and contexts now. So with that being said, I'll pass it over back to Dr. Horvat to moderate the questions.
Okay, thank you very much to you and to all the panelists. I think we have heard a lot of very different stories around the world, many different issues. I see now we have a few minutes time for questions and answers. And we already see one question that come from Isako dealing with a question. It's interesting to see that Seychelles and Tahiti studies did not detect adverse effect of mercury. Is there any quantified model that may explain how other factors such as unsaturated fatty acids or selenium compensate for the adverse effect of mercury? Let me pass this question maybe to Dr. Shroff and Dr. Masatake Fujimura. So who would like to take the floor first?
So I'm Masatake Fujimura. So we are now researching for the effect of selenium against methyl mercury toxicity, but so now I'm using animal model, but this is still in the research stage. So so it will be established in the future, the detailed rule of selenium, I think.
Thank you. Anything to add, Dr. Shroff?
Yes, so thank you for the question. And in terms of models that's quantifying, actually, we don't have any such data on this. I mean, we from the Safe Fishes survey, we've seen that selenium amount is quite high in the Seychelles fish also. But we have some evidence now with the N3 fatty acid showing that there are genes regulating PUFA metabolism, and we see like there's changes in terms of influencing the serum concentration of PUFAs, which provides the beneficial effects of methyl mercury poisoning, or sorry, exposure.
Okay, anybody else to add something to this? I would just like to update you on the fact that within the HBM for Europe project, there is one work package 12, which is led by the University Aristotle in Thessaloniki, that has now developed a model that take the real data from EPI study in the Mediterranean, and they will try to see whether they can come out with something better, but this is still a work in progress, and as the results become more evident. And what is very important in this kind of thing, you can also look into interaction, I mean, the presence of all mercury species and accumulation in target organs. And then you can look also into all these other aspects that can modify uptake, distribution, and eventually effects in human population. We will see where do we go there, but I think it's still a lot of research needed. Is there any other question? I see there is one, say no to mercury. Maybe Lisa Matriste, she has the opinion, say no to mercury. My question then relates, would you like to take the floor and explain? Lisa Matriste? Okay, I can read out. My question relates to the long-term studies of Seychelles in South America. I'm wondering if the mothers and children had mercury from dental amalgam included in the possible source pathway for mercury exposure. There seemed to be an assumption that their mercury levels were due only to their dietary exposure.
Milena, I just unmuted Ms. Matriste.
Okay, then maybe Dr. Lisa, would you like to explain or elaborate your question further? I have just read it as it appears in QA questions.
There, can you hear me?
Yes, we can hear you well.
Yes, it's Dr. Lisa from Australia here. Yes, with the, when I reviewed these studies many years ago, because I had been a dentist for 40 years, I did not come across any numbers of counting the number of dental amalgams in the mothers, and also if dentistry is used and mercury-based dentistry is used in these countries, there could be uncounted mercury exposure coming from dental amalgam.
Yeah. Thank you. Maybe Dr. Dorea, would you like Jose to reply here?
Okay, we had if I understood your question correct, we had a study showing a very good correlation between the number of amalgam fillings in the pregnant mother or lactating mother and the amount of mercury in their milk. In this line, I would like to say that the inorganic mercury from the mother it crosses better the memory barrier. However, it's less absorbed by the child. So you really do have an increase in the milk of lactating mothers with amalgam filling. But this mercury is less absorbed than the methyl mercury that may be derived from other sources. Did I answer the question?
Thank you, Jose. I would like to add to this that in the Mediterranean cohort study, Northern Adriatic, this information regarding the dental amalgams was very, very seriously considered in evaluation which biomarkers are best, where you have low-level exposure, long-term exposure, fish consumption, dental amalgams, and many others. And we have looked into meconium as a biomarker in this case, and we found that in mothers where the amalgams, number of amalgams were higher, we found higher levels of inorganic mercury in meconium. We have done a really speciation work there, and this has been published. And what the hypothesis here is that this is the elemental mercury that can pass the placental barrier as well as the brain. I mean, we know that elemental mercury has similar properties when it comes to crossing barrier as monomethyl mercury. And this, I think, needs to be considered, especially when we look at the low level of exposure and we miss potential other sources. So we see that we have to look at this very, very carefully. Meconium is a very nice, it's also a biomarker that can answer many of the questions. And also in the milk, when with a higher number of amalgam fillings, the levels of mercury in milk would also be elevated. At least this was the case in the Mediterranean, Northern Mediterranean cohort studies. Any other comment to this question? Now we have, Florian Schultz.
Can you still hear me?
Yes.
Oh, wonderful. So thank you very much that you are looking at this pathway. There is also the discussion of the various forms of mercury, whether it's organic, inorganic. What happens with dental amalgam, whilst it is elemental mercury that goes into the tooth, there is a significant bioconversion by oral biofilm, and that becomes methyl mercury, which is readily absorbed through the oral mucosa directly into the blood supply. And I believe that is also a significant area of research for its impact on cardiovascular disease.
Yeah, many of such things are really very important and need to be addressed. And I think this just still pushes very much to do more speciation work to really know what forms of mercury we are dealing with. As Neil said at the very start, inorganic mercury is not the same as elemental, and elemental is not the same as methyl mercury. And so I think this is exactly what you are suggesting here. Can we move now to the question posed by Florian Schultz? He is asking about, is the WHO going to include the phase out of dental amalgam in the global oral health strategy in line with the Agenda 2030, which is currently under development? Irina, would you like to address this question?
Yes, I start answering, but if you're allowing me, Milena, I would like just to also add to the previous discussion with Dr. Lisa, because I like very much say no to mercury. So nowadays we cannot exclude any source of exposure because we know a lot about mercury, but not all. So, and that's why we are talking about precautionary principle and the decision of European Union to do not use the dental amalgam for children and pregnant women. So it is like when we are not completely sure that there is no risk, the precautionary principles should come on the scene in order to predict the potential negative health impact. Okay, so thank you very much for question about phasing out the dental amalgam, and I start answering. And WHO is now implementing the JEF project, big one, with main focus to African countries, and the main of this project is to collect detailed information about what is going on with dental amalgams and to assess feasibility to phase them out instead of phasing down like it is decided in the Minamata Convention. And now I cannot answer the question if it will be possible before 2030 because dental amalgams are used widely and globally. And even European Union, the countries that have much more possibilities to transfer to non-mercury alternative for dental care, they are still discussing possibility to phase out the dental amalgam till 2030. So you can we can predict that it will be much more challenging task for less developed countries to completely phase out dental amalgam in healthcare. So we are going step by step, and I hope that it will happen, but most probably it will be more clear when we will have much more information, detailed information about the use of dental amalgam.
Thank you.
Always
Thank you. Thank you, Irina. I think we come close to an end, but there are some two questions in QA. Eisako, may I ask you for your help because I cannot see these questions in my box here. So perhaps before we close, we can just see what is there, and with this we would have to close the session.
Thank you. Thank you, Milena. Thank you all the panelists. So the question in the Q&A box is that the decision makers need to acknowledge the importance of the issue of hazardous chemicals, so that they can have a good scientific knowledge. And the reason why I asked the question on the quantification of hazardous effects is that we have been requested, for example, from the Jeff and other funding sources to demonstrate the benefit of funding that they are providing to the Minamata Convention. So we are we are under pressure to provide a scientific evidence or justification for the funding. So I think we are as the Minamata Secretariat, we are doing a quite small study on socio-economic impacts that we are going to present at the ICMGP. So this we are aiming at towards the same goal. So I think my response would be that we will join forces to move forward with the towards the good scientific knowledge. So this is my closing remark. I'm not sure whether Neil wants to say something at in closing, and I'm not sure whether Joy wants to say something. But so I will stop here and leave it to you, Joy, perhaps.
Thank you, Eisako. So from my side, just to say thank you very much to the presenters. I think it was a really excellent sharing of what is happening in the field in mercury health risk assessment. And thank you once again. And I look forward to our next session, which is Eisako on the 19th of November, right?
Yeah, I think it's 17th, but I will we will put it on the web.
Okay. Thank you very much once again, everyone. Thank you, Eisako, also for UNEP for hosting the event, and we look forward to the next one. Thank you.
Thank you. Have a nice rest of the day.